Hello, everyone. We're going to talk about 2.2 today, and that is the algebra of functions. Okay, so we're going to talk about things you can do with functions, and we can do the same thing with functions that we can do with numbers. We can add them, we can subtract them, multiply, and divide. This is the notation we will be using. We have to be super careful when dividing because you cannot divide by zeros. We have to be careful because when you divide, you're adding a risk. But the big thing is they'll have this notation like this, and all we're going to do is separate it into f of x plus g of x. On subtraction, when it has f minus g in parentheses like this, we'll separate to f of x minus g of x. You need to be careful on this one. You must subtract all the pieces, which will mean you're going to have to probably distribute. Okay, when you multiply f of x times g of x, you're going to have to double distribute or FOIL or just distribute. So you're going to have to be careful with this. And a lot of times when you divide, we are going to have that risk. So you're going to have to be careful of. But a lot of times this can't be simplified. And if it can simplify, you would have to factor. But I don't know if that's going to come up yet or not. Let's see what happens when we look at some examples. Okay, so here's a first example. We have a line and we have a square root. We keep in mind the square root does have some risk factors, so we can talk about domain for a minute here. A line has the domain negative infinity to positive infinity, but for the square root, that x plus 3 has to be greater than or equal to 0. So x is going to have to be greater than or equal to negative 3. We're just going to keep that in mind as we do these problems. So the first thing they're going to have us do is they're going to have us take f plus g of x, and all that is f of x plus g of x. And it's going to look pretty weird, but when we go to f of x and we get x plus 1, and we add to that g of x, which is this weirdo square root, that's just our answer. This cannot be combined any further. So the sum of f of x plus g of x is this guy. Now, what if we want to do f plus g of 6? Well, there's two ways you can do it. The way I think is the easiest is to take f of 6 plus g of 6. Well, what is f of 6? Go to f, take out the x, and plug in 6. 6 plus 1, that's 7. Plus g of 6 would be the square root of 6 plus 3, it's a little sloppy, which is the square root of 9, which is 3. 7 plus 3 is 10. I think that is the easiest way, f of 6 plus g of 6. Now, the other way you could do it is you could say, well, wait, don't I already have a rule for f plus g? And I did that right here. So you could plug 6 straight into this new rule we made, which is 6 plus 1 plus the square root of 6 plus 3, 7 plus the square root of 9, which is 3, and that gives you the same answer. So you can look at it separately, or you can plug it straight into our new rule. So why don't you pause it and try the next one, see how that works. Okay, let's see what I get. Well, what is f of negative 4 plus g of negative 4? F of negative 4 would be negative 4 plus 1, which is negative 3. How about g of negative 4? That would be the square root of negative 4 plus 3, and that is a problem. Negative 4 plus 3 would be the square root of negative 1, and we cannot have negatives underneath that. So we would say that this is undefined, or you can say it's not in the domain or something like that. So that will happen once in a while you're working with these functions. So like we just talked about the domains, we're going to be very careful. A lot of times we're going to have to look at our answer to see what's thrown out, and just keep in mind that division will cause us the most problems. So here's an example. X squared minus 4x. All these problems, they're going to have a lot. What they're going to do is they're going to have like a million parts on Math Lab. And they're going to ask you what the domain of all these is. So it'll say, what's the domain of F? And then it'll ask you for the domain of G. And then it'll ask you for the domain of F plus G, of F minus G, of F times G, and all this stuff. So you're going to be looking at these a lot, and don't let it trick you up. So let's do the domain of F first. This is a parabola. The domain of a parabola, there's no risk. So it's negative infinity to positive infinity. Well, what's the domain of G? Well, that is also negative infinity to positive infinity. So if I add F and G, I would get x squared minus 4 plus x plus 2. That's x squared plus x minus 2. Well, what's the domain of that? Well, it's another parabola. So that is also, the domain would be negative infinity to positive infinity. What if I subtract f minus g? Well, first I'm going to be really careful. Subtraction is a little bit harder because when you subtract, you're going to have to subtract all the pieces. So we will have to distribute x squared minus 4 minus x minus 2. Clean it up, x squared minus x minus 6. Another parabola. What's the domain of that? Negative infinity to positive infinity. How about when I multiply? F times g. Well, I'm going to take x squared minus 4, multiply it by x plus 2. How do you multiply two binomials? Well, we'll double distribute or FOIL. So that's x to the third plus 2x squared, negative 4 times x. Be careful, make sure you use that sign. Minus 4x minus 8. This is a cubic function. Still no risk. That's negative infinity to positive infinity. But what about f over g? F over g will be x squared minus 4 over x plus 2. Now, all of a sudden, we do have a risk. Look down here. X plus 2 cannot equal 0. That means x cannot equal negative 2. This does simplify further. Kids need to get good at this. This is difference of two squares. That's x plus 2 times x minus 2 over x plus 2. This is going to show up a lot. You guys have to get good at that factoring pattern. And then the x plus 2's would cancel out. So my answer is actually x minus 2, but x cannot equal negative 2. So you'll need to look at some factoring patterns you might have forgotten. We'll be able to go over those later as well. Okay, are these the same ones we just did? We just did all these. Did that one? Okay, let's do g times g. Well, what is g times g? That would just be x plus 2 times x plus 2. No risk factors. The domain is going to be negative infinity to positive infinity. When you double distribute, that's x squared plus 2x plus 2x. I'm going to go ahead and add those. Plus 4, which is x squared plus 4x plus 4. What if I did, I'm going to add another one, g over f of x. That means g of x over f of x. So now I have x plus 2 over x squared minus 4. X squared minus 4 cannot equal 0. You can either factor it or say x squared equals 4. When you square root both sides, x cannot equal plus or minus 2. So there's two things that could break the machine. You would still have to factor this. That's x minus 2, x plus 2. When those x plus 2's cancel, you have to put a 1 in its place, and that would give you 1 over x minus 2. So that's just another extra practice problem. Okay, what if you're looking at pictures? So F is this pink graph, and G is the blue graph. What is the domain of F? Well, the domain of F is starting at 0 and ending at 9, and we will use square brackets, 0 to 9. The domain of G starts at 3, goes to 10. So that would be 3, 10. So what happens if I add F and G? Well, if I add F and G, the only places I can add them are the places they have in common, which would be right there. So then that domain would be 3 to 9. How about subtracting? Subtracting, I would also only be able to subtract where they have in common. That would also be 3 to 9. When I multiply, it would have to be 3 to 9. But what about when I divide? Yes, it has to be where they have in common 3 to 9, but don't forget, you can't divide by 0. So we need to make sure G can never equal 0. Does G ever equal 0? Let's take a look. And it does not. So it would also be 3 to 9. Now, if I asked you for G over F, it would still be 3 to 9, but I want you to see what the problem is here. F cannot equal 0, and take a look. F equals 0 at 6, and at 8. So f can't be 6 or 8. So on this one, you would have to say 3 to 6 with a parenthesis, union, 6 to 8, union, oh, parenthesis there, 8 to 9. I don't think that's going to come up, but if you're looking at the graphs, make sure you do not divide by 0. And now they actually want us to graph f minus g. So what I'm going to do is I'm going to take the pink graph and I'm going to subtract the blue graph. So on this first line right here, I'm going to take the pink number, which is 3, minus, I'm a liar, the pink number, which is 2, minus the blue number, which is 1. 2 minus 1 is 1. So that goes there. Now I'm going to take on this next line, the pink number, which is, looks like 2, minus the blue number's right on top of it too. So my new graph is going to go at 0 on that line. On this line right where the 5 is, pink is at 1, minus blue is at 3. 1 minus 3 is negative 2. So on this line, we're going down to negative 2. Let's go to the 6th line. Pink is 0, minus G looks like 3.5. 0 minus 3.5 is negative 3.5. Should be right about here. On the next line, pink is negative 1, minus 4, be negative 5, which would be way down here. On the 8 line, pink is 0, minus 3. 0 minus 3 would be negative 3, so we're coming back up. And at this last point, pink is 1, minus 2, which is negative 1. It looks like my graph's going to kind of go like this, maybe. This would be multiple choice, but that's how you're going to do that. Just subtract those pieces. Okay, this difference quotient. First thing you're going to ask me, do I have to memorize it? The answer is no. It will be given to you in every problem that you'll see. But here's what you want to know about the difference quotient. This is an idea we'll use in calculus. And what this is a rate of change formula. You have seen the word rate of change before. Rate of change is another word for slope. However, only lines have slope. Everything has a rate of change. So if they ask you to do the difference quotient on a line, it's the exact same thing as the slope. If they ask you to do it on a quadratic, which you will have to do that one time, and it will be tough, then you have to do all these pieces, and we're going to have to do some complicated algebra. And it will be a tough question. You'll ask me to do a couple of these with you, and then you'll get pretty good at it. But you need to know that the difference quotient is the rate of change formula. So if it's a line, it's just the slope. So let's take a look at it. For the function, f of x is 2x minus 3, find the difference quotient. Well, I just told you, that's the rate of change formula. So the answer is going to be 2. Now, I'm actually going to show you how we're going to do this with the algebra on this problem where we already know the answer. But on a test or quiz, as soon as you see this question, you'll be able to go straight to the answer with no work on this. But I am going to show you what the work would look like. So the first thing you're going to do is you're going to take f of x plus h. And what this is it's just saying if f of x is y, this is just a step away from that, some distance h away. We don't know how far. So we're going to go to function f, take out the x, and put in an x plus h. And there's a minus 3. It'll look kind of like the original equation, 2x minus 3. Clean it up, 2x plus 2h minus 3. That's f of x plus h. We will now subtract from that f of x, because we're going to take f of x plus h minus f of x. Well, f of x was 2x minus 3. And then you're going to put all of that over h. So we're going to clean it up. This will have to be distributed. 2x plus 2h minus 3 minus 2x plus 3 all over h. Keep cleaning. The 2x minus the 2x, the negative 3 plus the 3, and you're left with 2h over h, which simplifies to what we knew the answer would be, 2. So this is telling you the rate of change for the line is always going to be 2. On the next equation we're going to do with the parabola, there's going to be h's in our answer because it will depend how far away the points are. What the slope is going to be, it will depend. So that's why there's going to be h in place still. So let's look at the next one, and this is as hard as it gets. And this is pretty hard, I'm not going to lie. They want to know what the difference quotient is. It's not a line, so it's not the slope, which means we're going to have to math. So the first thing we're going to do is f of x plus h, and this is the hard part. Go to function f, take out the x, and put in an x plus h in parentheses. Well, this is the part that's hard, and this is the part you're going to mess up. We talked about this earlier. X plus h squared is x plus h times x plus h. That's x squared plus xh plus xh. That's 2xh plus h squared. That's some good algebra right there. So this is 2 times x squared plus 2xh plus h squared minus x minus h minus 3. We'll distribute, and we get 2x squared plus 4xh plus 2h squared minus x minus h minus 3. And there are no like terms. That's what it looks like. Now we will subtract f of x, which is 2x squared minus x minus 3. Why are we subtracting that? Because that is what the formula is. F of x plus h. Now we're going to subtract f of x. They're going to put that answer over h. This will distribute, I'm going to write it right below it to save some space, minus 2x squared plus x plus 3. If you do that correctly, something will cross out with each of those terms. And it did. So all you're left with now is 4xh plus 2h squared minus h, and all of that goes over h. And there's an h in common everywhere. So you love math, and we clean that up. We cancel the h out of everybody, and you get 2x plus, I'm a liar, not 2x. You guys are probably mad. You get 4x plus 2h minus h over h is 1. So this is your difference quotient. So basically it's 4x minus 1 plus whatever the step away from each other is. So that is the difference quotient. That is tough, and it will be tough. We'll have some time to do some questions together. That's it for your notes today.